Related Rates Video Project, Jean Lee, Period 2.
Use a hand sanitizer with at least 60% alcohol.
Medical grade hand sanitizer. So
the hand sanitizer you're using in
1,000 bottles of sanitizer after the U.S. saw
the demand out.
Your hands clean is one of the best ways to.
As hand sanitizer flies off the
물론이고 소독제의 주성분인 에탄올 확.
Está desinfectante de manos.
Wait a minute.
A hand sanitizer bottle in the shape of a rectangular prism is being used. We know that the bottle is 9 centimeters long, 3 centimeters wide, and has a height of 15 centimeters. If Jean were to consistently pump the sanitizer till it was empty, the height would drop 0.5 centimeters every minute. How fast is the volume of the hand sanitizer changing? Let's start by highlighting the important information. We know the shape is a rectangular prism, and we also know the dimensions, 9 by 3 by 15. We also know that the hand sanitizer drops 0.5 centimeters every minute. We want to know how fast the volume of the hand sanitizer is changing. Before we start solving the problem, we'll go over with what we know. We know that the shape of the bottle is a rectangular prism. We also know the dimensions of this prism. It is 15 centimeters in height, 9 in length, and 3 in width. We also know that there is a change in height. Remember that this is not a change in the height of the bottle, but of the liquid inside the bottle. It's changing at a rate, and this rate is written as dH over dt, which is the height in centimeters over the time in minutes. This rate is 0.5 centimeters per minute, or 1/2 centimeters per minute. Now, what do we need and what exactly are we looking for? Well, we're looking for a change in volume. The question asks how fast the volume changes. This is written as dV over dt, volume over time. Now let's begin solving the problem. In order to begin, we need an equation. We'll be using the equation of a volume of a rectangular prism, which is V equals L times W times H, length times width times height. We know that L and W are 9 and 3. However, H is still H because it is not a constant and is changing. This is written as V equals 9 times 3 times H, which is simplified to 27 times H. Once the equation is simplified, it's time for implicit differentiation. This is taking the derivative of both sides. D over dt symbolizes the derivative. The derivative of 27h is 27, and the derivative of h is dh over dt, and the derivative of v is dv over dt. Now, we need to find dv over dt, but in order to do that, we need to find the value of dh over dt. However, we already know that this value is 0.5 centimeters per minute. If we substitute 0.5 into the equation, we'll get 13.5. That means dV over dt equals 13.5. This means that the sanitizer decreases 13.5 cubic centimeters every minute. This is the rate. The bottle will decrease 13.5 centimeters per minute. Yay! Remember, related rates must deal with at least 2 related variables with respect to time. In this example, the objective was to find the rate of change. Related rates come in many different forms such as triangles, spheres, cylinders, circles, cones, and etc. It is time for implicit Okay.